Hello there, Mr. Sutton here, bringing you the Algebra 2 3-5 lesson on solving nonlinear systems of equations. So for the honors, this will be a one-part lesson. For the non-honors, this is going to be a two-parter. In any case, for both of these, we're going to be solving nonlinear systems using a variety of methods, including graphing, substitution, and also elimination. So just to get a definition out of the way before we dive into our first example, when we talk about a nonlinear system, we are talking about a system with at least one nonlinear function. Now it is important to note that we could have one linear function in the system. It's okay if there are linear functions in it, but at least one of them is not linear. So with that in mind, here's an example of such a system. So for this one, we have this y equals x squared minus 2x minus 1, which is not a line. We know that is a parabola. And then we have y equals negative 2x minus 1, which is a line. So again, we could have something that's non-linear and linear together. Or we could have multiple things. Everything is non-linear. They all count as non-linear. So this one, we're just trying to solve the system by graphing. So really just pause the video and take a moment on Desmos and see where these two intersect. Alright, so I've opened Desmos here. All we have to do is literally just type these in. So we got x squared minus 2x minus 1. And we also have y equals negative 2x minus 1. And let me just move this over so I can actually see it. And it looks like, let's zoom in a little bit here, because it's hard to see what's actually the crossing point. It looks like this little spot right here. There's just one little spot of intersection. So that's at 0, negative 1. So there's the graph that I just saw. We have 0, negative 1. And if you wanted, you could actually still just plug your point in to see if it actually works. So if I plug in 0 for all the x's, all that's left is negative 1. So that equals the negative 1 y value. Over here, if I plug in 0, I get negative 1 as well. So it looks like that works. For this next problem, they're asking us to solve this equation by graphing. Now, this is actually very similar to the first example we did that had a system of two different equations. In this one, we have a single equation. However, you can actually solve this if you just graph each side of this equation as its own separate function, and then just see where they intersect. So, pause the video and give that a shot on Desmos. Alright, so on Desmos, let me show you how we could do this. See if you got the same answer as me. So we have y equals 3x squared plus 5x minus 1. And in fact, you don't even need to write the y equals. It'll still graph it for you. And then let's go down to negative x squared plus 2x plus 1. And let's just bring this up so I can see everything and maybe zoom out a little bit. I'm still zoomed in from the last problem. So we've got two spots. One is right here at negative 1.17 and some change, comma negative 2.7. And up here also at 0.4, comma 1.6, 1.7. So write that out with however much accuracy you feel you need to. There's our picture again. 3 decimal places is usually a good rule of thumb if you're not sure how far to take it out. So there was our first intersection down there, and our second intersection up here I'll just write as our official second answer. For our next few examples, we're going to be getting into some algebraic approaches, non-graphical approaches to solving systems of nonlinear equations. And while we do it, for this first one, I'm just going to incorporate kind of a real-life setting. So let's say that we have this Tower of ride at Six Flags. It's an imaginary theme park. And here's what this thing looks like. So we just press the ride button, and that launches people up this thing. And then they go back down. Woo! Lots of fun. We could do it again. Let's ride it again. There we go. So much fun. So anyway, the way this works is that the ride, the height of the ride, we actually have an equation for this. H equals negative 16t squared plus 130t. And so that this negative 16 we've seen before. That is, again, gravity. And this 130t, this is our initial upward velocity, if you were curious. So we also have a camera taking riders' pictures on the way up and back down. So let me show you what this looks like. So we go click on the way up and back on the way down. Very cool. The height of this camera is not a quadratic. This one is actually a linear function, 18t plus 96. So what we're curious in is when should this camera be programmed to take a picture, and how high will it be, and the rider also, because they'll be at the same height at those times. Now yes, we could make it like motion sensitive and modern and all that, but maybe we didn't feel like spending money and we just want to program it with times. So pack your bags, put on your seatbelt, and let's go on this ride. Woohoo! And figure out when those times are going to be. Alright, so here's our two equations that we're trying to solve this system by substitution or elimination. You can actually use either approach. So it's looking to me, since we have h equals on both of these, we've already got a variable isolated. Substitution would probably be the fastest approach here to getting one equation out of all this. So we can replace one of these h's with the stuff that the other h equals in the other equation. So for example, we could do negative 16t squared plus 130t equals 18t plus 96. That's one way you could start this problem. There are certainly other ways. But with this way or whatever other way you want to start it in mind, pause the video and see if you can use a little quadratic math to figure out the value of t and the values of h that have to go with that. Alright, so getting to the bottom of this one, in order to make any progress on this, it would probably be best if I just move everything over to one side. With quadratics, unless you're going to be completing the square, every other technique generally you want to move everything over to one side. So let's keep the negative 16t squared where it is for now. And the 130t, I can subtract 18t from that, so that'll be a plus 112t. And then subtract the 96. Now I'm wondering, before I go quadratic formula on this thing, could I divide by something like negative 16, for example, and get a much nicer equation? Well, this first term would become t squared if I divided by negative 16. How about 112? Let me just calculate that. 112 divided by negative 16, does that come out to a nice number? Ooh, negative 7. Nice. So actually, let's go this way. And then 96, negative 96 divided by negative 16, I happen to know that that's going to be positive 6. Well, this is much easier than a quadratic formula problem now. We just need two factors of 6 that add up to negative 7. And 1 and 6 does the job. First time's the charm. So if they're both negative, it'll work. So we'll have t minus 1 and t minus 6. And now we just have to zero out each of these factors. So we're going to have t equals positive 1 and positive 6. Now, one thing that's a little bit different solving one of these versus a regular system of linear equations is that since we have these multiple answers, for each x value or t value, whatever value, you have to plug that back in to find the corresponding output value, which is usually a y value, but in this case would be an h value. So let's go ahead and do that. And since this is a system of equations, since these hold true for both of these equations, it doesn't actually matter which equation we plug these into, at least in terms of getting a correct value. However, one of these equations might be easier than the other. I'm thinking this 18t plus 96 is way easier to work with than this other one. So let me do 18 times 1 plus 96, and I can just do that in my head. That's 114. And we're going to want to write a point with the correct x's and y's together, because that, if we have multiple x's and multiple y's, there's no way to tell which ones go with which unless we put them together in a specific point. So this would be 1 comma 114. And in terms of our real life problem, this is basically saying after 1 second we're at 114 feet, and that's one place where the camera is going to go off. Now let's do this t equals 6. So we've got 18 times 6 plus 96, and I will use Desmos for that. So 18 times 6 plus 96, that comes out to 204. So we have 6 comma 204, 6 seconds, 204 feet. That's the other place the camera goes off, most likely on the way back down. So this next example is an additional substitution-y kind of problem here if you're taking the non-honors version of this lesson. So if that's you, then pause the video and give this one a shot. You might need to rearrange things to get a variable by itself first. If you're doing the honors version of this lesson, then you can just continue on to the next example. Alright, so let's see how this one went for you. Out of the two equations, I'm thinking probably it would be easiest to isolate a variable in this bottom equation here. And I have to be a little bit strategic about which one I isolate. So do I want to get rid of, in this first equation, do I want to get rid of the y or the x's? Well, I don't know. I feel like it would be easier if I just swap out this y for something with an x. So to do that, I need to isolate the y in this bottom equation, which I can quickly do by just subtracting x from both sides. Not the only way I could have done this, but pick a direction and start walking. So since I've got this isolated here, now I can plug in 4 minus x for this y up here. But when I do that, I'm going to want to use parentheses so I don't lose anything. So now if I distribute this negative, I've got negative 4 plus x, which makes a big difference toward the final answer, and then we still have that negative 1 over there. This is a quadratic. It's just a 1x squared, so I have a feeling if I move everything over to one side, I can probably factor this, but we won't really know until we do it. So the x squared can stay where it is. X plus x is 2x, and then we have a negative 4 plus this 1 giving us negative 3. Well, let's see. Two numbers that multiply to negative 3 and add up to positive 2. We really only have one option, and that's a 1 and a 3. If I make the 1 negative and the 3 positive, this works out. So I can rewrite this as x minus 1 and x plus 3. And then zeroing each of these out, we've got x equals positive 1. And I'll deal with the 3 in a minute, but let me just kind of finish this branch. I'm going to start doing that, is working on one branch at a time. So if I plug in 1 to get the y value back, the easiest equation to do that in is going to be this y equals 4 minus x that I rearranged. So I can write y equals 4 minus 1. So that's 3. So we have the point 1 comma 3. That's one of our answers. So that was where x equaled 1. Now if x equals, for this one, if x plus 3 equals 0, we can say x equals negative 3. And now if I plug that in, we have 4 minus negative 3, which is 4 plus 3, or 7. And that gives us the point negative 3 comma 7. So those are our two answers for this one. So if you're doing the CP non-honors version of the lesson, this is the end of part 1 for you. You can pause the video and do some practice problems and come back for more. If you're doing the honors, again, you probably already skipped over this, but if you didn't, just move on and we're going to keep going. All right, well, if you're doing the CP version, welcome back. This is part 2 for you. If you're doing the honors, then you're still here. You were here already. So let's keep going and see how else we can solve these sorts of problems. So the last example, or two, we did with substitution. So elimination is also an option. Just to review, that's when you essentially add equations together and it cancels out one of your variables. And if you're going to do this, you're going to want to make sure the variables you're trying to cancel are on the same side of the equations. So one thing that's also good to do in these situations is to label each equation. So I'm going to call this first one E1 and this one E2, and that just gives me a very quick, succinct way of talking about what I'm going to be doing with the equations. So in this case, I noticed that if I were to add these two equations together, these y's would cancel out. So just to tell people what I'm doing, I'm going to write E1 plus E2, and then I'm actually going to add these out together. So with that little hint in mind, pause the video and see if you can take this the rest of the way. Alright, so adding these together, we cancel out these y's here. That leaves us with a 2x squared that and an x squared adds up to 3x squared. And then we have negative 5x and 2x. That's going to add up to negative 3x. And then finally, over on the right side, negative 2 plus 0 is going to be negative 2. So we can tell pretty early in the going here that this is not going to be just a simple, easy factoring sort of problem. It might be factorable, but who knows? Just on the off chance that it isn't, I'm going to zero things out, and let's just use the quadratic formula on this one. We could try factoring it, but it would probably take just as long. These are small numbers to plug into the quadratic formula. So moving that 2 over to the left side here, now I've got this in standard form, and I can use my quadratic formula. Here is that formula again, negative b plus or minus square root of b squared minus 4ac all over 2a. So we've got negative 3 for that b value, plus or minus the square root of negative 3 squared, minus 4 times the a value 3, times the c value 2, all over 2 times the a value 3. Simplifying that a bit, we have a positive 3 up here and a 6 down there. We have 9 inside the square root, minus, this is 12 times 2, so minus 24. And that comes to a grand total of negative 15 in there. Now we could keep simplifying this, but honestly, since you're actually looking for a real x value or y value here, the moment you notice you're going to get something that's imaginary, you don't have to keep going. Once we recognize that this is not going to be a real number, we can just write no solution and get on to the next thing in life. Now it is worth noting that with a line and a quadratic or two quadratics, in all of those situations, there's actually kind of 3 different results we can get for problems. And we might as well talk about this now. So we already saw a problem or so where we intersected twice. That was on our substitution amusement park problem. We saw on one of those graphing problems in the early going that we could also intersect exactly once. That was with a line and parabola, and if you have 2 parabolas, you could also intersect once, for example, if they share a vertex. And we've seen here that they don't actually have to intersect at all. This is what would happen if you have no solution, is your graphs just don't intersect anywhere. So at this point, if you are doing the honors version of the lesson, this was actually your last part of the lesson, last example, so you're done. You can turn off the video if you want and try out that practice set involving the whole lesson, or you can just tag along and see what else is going on. If you're doing the non-honors CP version, we got one more example for you. So here's another example that you may want to try with elimination. You could certainly do anything you can do with elimination, you can also do with substitution, but let's try the elimination approach on this one. So there's a little bit more going on this time around. You might notice that if we were to just add these equations, which I will again call E1 and E2, if I were just to add these together, the y's in this case would not cancel out. The y's don't have to cancel out. You could get the x's to cancel out, but that's a lot tougher when you have like x squareds and x's and all the other things. Y is going to be easier to get them to cancel, but they're not going to cancel. So what could we do first before we add these together? Well, you might remember from working with systems of equations that you are allowed to multiply one or both of the equations by a constant to change it so that you do get numbers that will cancel out. So with that in mind, pause the video and see if you can figure out what you need to multiply one of these by, and then take it from there. Alright, so I recognize that if I multiply either of these equations by -1, that will give me a negative y in one of these spots, and then things would cancel. So I'm going to choose to multiply my first equation by -1. Part of why I'm doing that is because that will make this negative 10x squared positive, which I kind of like that. So let's do negative e1 plus e2. So rearrange or changing the signs on our first equation, we now have 10x squared minus y, and this is really why we did this, equals 80x minus 155. E2 we're not going to change a bit, so we'll just copy and paste it down here. At this point, let's go ahead and actually add these together. So the y's are going to cancel. we've got 15x squared equals, over here now we have 120x, and negative 155 minus 85, that's going to be negative 240. When in doubt, zero it out. Let's get everything on the left side here to either use factoring or quadratic formula. So we have 15x squared minus 120x plus 240. And I might be able to divide everything by a constant first. Let me see if I divide everything by 15, what happens. That gives me x squared minus, let's see, I think that's going to be 8x. And then plus, this will be, well, let me go to Desmos here. 240 divided by 15, it gives me 16. Well, that worked out way better than expected. All right, so we actually have one of those perfect square sandwiches that you completed the square with a bunch. If we square root both of these, we have x minus, because we have a minus here, 4 quantities squared. Or you could ask for two things that multiply to 16 and add up to negative 8. That would be negative 4, negative 4. Either way, we see that x is then going to equal 4, because 4 minus 4 is 0. So that's good. We still need to plug this back in to get the y value, though. But just worth noting, kind of an aha moment, this is one of those problems where you have exactly one solution. So now, which equation do we want to plug this back into? I'm thinking between the two equations that we started with here, E2 looks a little bit nicer. I mean, they're both not great, but we'll go with E2. So that'll be 5 times 4 squared plus y equals 40 times 4 minus 85. And I could probably do the rest of this without a calculator. 4 squared is 16 times 5 is 80, so we have 80 plus y. And on the right side, this is going to be 160 minus 85, which is 75. And then just one more little step, subtract 80 from both sides. We have y equals negative 5. So then 4 comma negative 5, final answer on this one. So that's the end of this one. You've been given a variety of tools for solving these systems of equations. At the end of the day, it probably doesn't matter if you lean towards substitution or elimination, as long as you've got a system. Till next time, Mr. Sutton signing off.